Hello and welcome to Pre-Cal Lecture 3.4. Pretty short lecture where we're going to be talking about finding the x and y intercepts of a function, because this can help you graph a function. So go ahead, if you want to pause the video and go ahead and copy all of this down. I went ahead and put it all on the board just to save a little time on the video. But finding the x and y intercepts of an equation. So the x-intercept is where a function crosses the x-axis, and the y-intercept is where a function crosses the y-axis. So you can see the graph here, just where this nice curve crosses the x-axis. What I drew crosses it in two places. Those are the x-intercepts. And then the way I drew it, I crossed the y-axis in one spot, so that's called the y-intercept. So in order to find the y-intercept, we let x equal 0 and then we solve for y. And to find the x-intercept, we let y equal 0 and we solve for x. So I've got 3 examples, and then we'll talk about the homework. So our first example is find the x and y intercepts for 2x plus 5y equals 12. Okay, so let's find the x-intercept. We're going to let y equal 0. So for this function. So we would have 2x plus 5 times 0 is equal to 12. So that would be 2x is equal to 12. So x is equal to 6. So the x-intercept is at the point 6, 0. Okay, because the y value at an x-intercept will always be 0. So at the point 6, 0. And then the y-intercept, we're going to let x equal 0. So I would have 2 times 0 plus 5y is equal to 12. So the 0 part goes away. 5y is equal to 12. So y is equal to 12 over 5. So the y-intercept is at the point 0, 12 over 5. Okay, remember the y-intercept always will have an x value of 0. So that's our answers. We could, it's pretty easy to graph this. So we know that there's no x squared or y squared, anything like that. So this is just a line. We know the x-intercept is at 6. The y-intercept is at 12 over 5, which is like between 2 and 3. So let's say that'd be about right there. We know it's a line, so we have our 2 points. So we pretty much know what that line looks like. It's got a negative slope. We know where it crosses the axis. So yeah, and you will, in a couple of places on your homework, need to sketch the graph. So you can do that if you know the intercepts. It really helps in sketching the graph. All right, let's do some more examples here. All right, we can go ahead, I think, and erase all these initial notes. So our next example is find the x and y intercepts for y is equal to x squared minus 4x plus 3. Well, it helps to know the base. If we're going to have to graph it, what's the shape of this? Well, it's got an x squared term. This is a parabola. It's a happy face parabola. The minus 4x and the 3 just moves it around the graph a little bit. We know the basic shape is a happy face parabola. So to find the y-intercept, got the I. Find the y-intercept, we're going to let x equal 0. So we would zero out this term, and all we have left is y is equal to 3. So the y-intercept is at the point 0, 3. Now finding the x-intercept is going to be a little more difficult. So we would have 0 for y is equal to x squared minus 4x plus 3. Well, how do we solve for x? Well, we've done this a lot. We're just going to try and factor. Now, if it doesn't factor, you could quadratic formula it, but I probably wouldn't give it to you if you couldn't factor it. So you've got x, x. How about minus 3 minus 1? So that'd be x squared minus 3x minus x. That'd give you negative 4x, and negative 3 times negative 1 would give you positive 3. So x is equal to 1 and 3. Right? 1 would make this parenthesis negative. 3 would make this parenthesis negative. So our points that are x-intercepts, so this is our y-intercept, and our x-intercepts would be at the following 2 points, 1, 0, and 3, 0. Now let's say I asked you to sketch the graph of this. Well, we know it's a parabola. We know we have an x-intercept at 1 and at 3. And we have a y-intercept at y equals 3. So we can put that, let's say, right there. So we know that it crosses there. So it would be something like, just taking a guess here, the vertex about there. You know, something like that. So you can get a pretty good sketch. And we could confirm that with our graphing calculator. But yeah, so pretty cool. All right, let's do the last one. Then we'll look at our homework a little bit. And it's going to be find the x and y intercepts. So I'm going to leave that there. So this one, it looks a little bit different. The function is x equals negative y squared plus 4y plus 12. Now when y term is squared, that is a sideways parabola, and with the negative in front, the parabola points towards the left. Okay, so a sideways parabola. So I'm going to go ahead and write that out. Sideways parabola. Now I wouldn't ask you on a test to sketch a graph like this, and your calculator is going to really struggle to do a graph like this. It wants y equals. However, I'm going to show you how to sketch it anyway. So let's let y equal 0. Then your x, then you had this is zeros, x is just 12. So we have an x-intercept at the point 12, 0. So one of them is usually really easy to find. So now let's let x equal 0. If you do that, we have 0 is equal to negative y squared plus 4y plus 12. Now, I hate trying to factor when a negative's in front of the square term. So I'm going to move all of this over. change the sign. So we'd have y squared minus 4y minus 12 equals 0. That's just my personal preference. So to factor this, we'd have y, and to get a 4, I think it's going to be a 6 and a 2 there. So how about minus 6 plus 2 would give us that negative 4 in the middle. So we would have y is equal to negative 2 for this parenthesis and 6. So our y-intercepts are at the points, and I want you to list them in terms of a point. At the point 0, negative 2, and 0, 6. So let's see if we can use that information to sketch the graph. Now I know I mentioned it's a sideways parabola and it's opening up to the left side. Okay, so I know that we have y-intercepts at 6, so let's put that up here, and negative 2. We'll put that down here. And we have an x-intercept at 12, so I'm going to put that way out here. So the basic shape, your vertex would be in the middle of these two. So it's going to be, this is not perfect, but it's going to be something like this. Can be really helpful to know. So the vertex would come in the middle of these 2 points right there. So basically that's what it looks like. Okay, the homework is going to be worksheet 3.3, 3.4. I just want to take a look at that real quick. So the first couple of them are greatest integer problems. So we talked about that in lecture 3.3. I do want you to do a rough sketch on number 3 and number 6. And then I would like you to graph on a calculator number 3, number 6, and number 7. Okay? So if you've forgotten how to graph, now for number 3 to graph it, you're going to have to divide both sides by 9. So that would have to be 2/9 x squared and then 18 over 9 minus 2. So you need to set it equal to y. So let me clear this. So to graph, you want to go to y equal. I'm going to clear out anything that's there. And let's just graph a parabola. How about 2x squared plus 2. So we're in the y equals section here, and I'm going to do 2. We go to alpha and hit x, and I'm going to square that, and then right arrow to get off the exponent, and then plus 2. Okay, so I've got y sub 1. We were in the y equal. Now I'm going to hit the graph function, and you can see it's a parabola. So just do that, sketch it out like I did on the notes, and then the only reason I included this in here is to remind you how to use your TI-84 to graph something. Okay, so you should have done that in Algebra 2 quite a bit, using the y equals section and the graph. And if you can't get it to work properly, then let me know on Teams, and maybe we can see what's going on. Maybe some of your format settings are messed up and you need to adjust those. All right, so that does it for this lecture, and I'll talk to you on the next one.